Hello and welcome back. Today we're going to work on actually resizing our view into the game. You can see that our game Framebuffer texture now takes up the entirety of the window to the best of its ability to maintain an aspect ratio. So if I resize this, you can see we're maintaining that aspect ratio. I've chosen 16:9 here, and ImGui itself is going to properly reposition this so it's nice and centered. And you see we're never able to cut off the view into the game. We just have these sort of black bars on the side. Additionally, with a button press, I'll be able to turn off ImGui and look at the game actually being rendered back on screen again, which is something we actually removed a couple videos ago. And similarly, I can resize the window, and I'll now again adhere to my aspect ratio, and I'll immediately add black bars to ensure that the game is always rendered at the same aspect ratio that I care about. So as always, remember to click that subscribe button, give me a big thumbs up, and let's get into it. Let's take a look at what we've got right now. This is what we have right now. As you can see, we're rendering our game view to this panel, but we're not resizing it, so I can actually cut it off and I can't visually see the entirety of the screen. Similarly, if I move this around, this should resize to properly fit within a certain aspect ratio. And obviously, I can't turn off ImGui right now, right? I can't look at what is actually being rendered on screen if I was to sort of ship this game. So let's start first with, let's just go down to the ImGui render and turn off the dock space for a second. Yeah, so everything sort of stays where it is, but this is what we've got, right? And the problem is that our game view obviously has a white rect in it, but we don't see that in the main window, right? We just have our default clear color. So we should actually be able to enable rendering to the main screen and almost like just disabling ImGui altogether if we want to just look at what our game would look like to the end user. Also, this is I'm tired of the size of the screen. It's kind of small, so let's just increase it a little bit. Let's just go up to here. Let's make it 1280 by 720, proper 16:9 resolution. Nice, that's better. And yeah, let's actually start rendering to the background now. So maybe in window.h we can have, because we might not want to render to the screen. If we render to the screen, that's an additional render call because we have to, we're rendering everything to the frame buffer. We'll have to render that frame buffer to the screen. So let's just add the ability to toggle that maybe down here for screen render. And we'll just add a setter up here. Great. Now the rendering call itself for the final renders to the window or to the screen here doesn't necessarily have to go through our deferred rendering pipeline. This is going to happen at the very end when we know we've already rendered everything, because obviously we need to render everything to the frame buffer before we know what we're rendering to the screen. So either way, that means we still need, we have a frame buffer. We're going to need a vertex array and a shader here. Right, because we need to know how to render this thing on the screen. And then we'll just add them down here. Okay, and switching over, we'll need to include vertex and shader. And then when we create everything, we can start setting everything up for that vertex array and shader. Maybe I'll bring this out into its own function. Let's just call it initialize screen render. And that way we can just put the code down here. And I'm just going to sort of steal what we have in main.cpp for, I think, everything, because we have a normal rect vertex array, and we have a normal textured shader. So I'll just take these two and put them back here. So we want the vertex array. This is now in normalized device coordinates, right? Because we're not going to use a camera for this. It's just going to go right on the screen. So this will want to go from -1 to 1, right? And because they're -1 to 1s and we know we're not pushing floats, we can actually make these shorts. And we can even couple, so it's just an X and Y. I know I don't care about a Z. and we can couple the texture coordinates in here as well. So where were the here? So this is a better representation of what we want. So we want shorts, and then anything that's positive will just be a 1. And then I'll do the X, the Y, and then we'll do the U and the V, so 1, 1. Okay, and then 1, negative 1, and then the second row down here is 1, 0. Negative 1, 0, 0. And then negative 1, 1, 0, 1. Perfect. Let me just space these out nicely. So this is the X and the Y of the vertex, and this is the U and the V of the texture mapping that we care about. So this will be a 2, 2 layout. Now I don't want to declare a new VA here. I have my screen VA that I want here. So mScreen VA equals make shared vertex array, and then we'll push this vertex into it. And we don't need the second vertex, it's just one vertex buffer of shorts. Perfect. We'll set the elements as they are, and we'll upload it. No library. Okay, that's screen VA, and then for the shader, we'll just use the texture shader down here. Now we don't even need this extra scoping here. And this will be screen shader equals make shared vertex shader fragment shader. Okay, and then the shaders themselves, it's going to be a vec2 of position, a vec2 of text coords, and then we'll push out the UVs as always. We don't need a projection or a view matrix because there's no camera, right? We know exactly where we're going to put these vertices, so there's no need to convert screen space or anything like that. So position text coords will have the UVs, a model matrix. We'll push the UVs through from text coords, and then we'll just say model. And the reason we still want a model matrix is because we might have to move the screen around if we want to maintain a certain aspect ratio, but our window size doesn't adhere to that aspect ratio, right? You see this in games where they have like a black bar on the top and bottom of the screen or left and right to sort of center the content at the resolution they want to keep the content at. So we're going to do the same thing here. So we'll have a model matrix for that. And then the fragment shader, we'll just take out color, take in UVs, sample 2D, and yep, we'll just sample the texture directly. So we'll keep that as is. And then we'll set the screen shader. Perfect. And now I should have a bool. Yeah, bool render. So m should render to screen. We'll have to give it an initial value here. And I think I'll just set it to true. And then if you really don't want it, you can turn it off. Okay, so now the actual render part, when we're done rendering, so end render here, here's where we say, okay, everything that the client has wanted to render should now be flushed. And we pop the final frame buffer and we flush it. So at this point, we know that all of the render commands will have been executed against this frame buffer. So now we know the frame buffer has an updated texture with our scene for that frame, and now we can actually render it to the screen. So here I can say, if m should render to screen, then we'll add a rendering code here. And again, I'll probably pull that out. So let's call it render to screen. Put it down here. Okay, and we can put this guy down here. And so I guess the first thing I want to do is check that my screen VA is valid. And do I have a validity check on the shader? I don't. I think I'll just assert if it fails to compile, but I don't like track that, so there's nothing for me to check against. That's fine. I'll just check against the screen VA because this could fail without us asserting because we just might forget to call upload. So let's do a hippo assert. Screen VA. I think I have the is valid check. Yeah. Yeah, I'd like you to call vertex array upload. Okay. So if it's valid, we'll bind it. So the next step is to bind the texture, but I don't actually have like a texture object, right? I just have the texture ID from our frame buffer. So I'll just bind that directly in OpenGL. I think it's on frame buffer. Yep. get texture ID. Yep, perfect. And then we'll bind the shader. Then we'll unbind the shader. Bind texture, GL texture to D0, and then unbind the screen VA. And then here's where we actually draw, and I think it's just going to be like a GL draw elements, right? With GL triangles, M screen VA, get element count. For the count, the type is GL unsigned byte, or sorry, unsigned int. Yeah, our elements are unsigned ints, and then no offset, 0. Perfect. That's pretty much all we need to do. So let me just try and run this. That should be pretty straightforward. Okay, error compiling shader. What do we do? Too little data in type constructor. Okay, line 11 in the vertex shader. Of course, when I say it should be simple, we have an issue. Vec2 position. So this is line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Model, yeah, position is only 2 coordinates now, so I have to give it a third coordinate, 0.0, for the Z value. There we go. So there, we're rendering to our screen, and I should still be able to change this to rect textured, and there it is, rendering in perfect 16:9 resolution. Now the next thing is when I resize this window, you can notice that the entire screen gets stretched, right? So I'm still trying to render a 16:9 pixels, but into a smaller space. And this is not what we want, right? What we like is to maintain the aspect ratio so that the image isn't stretched like this. And we do that by shrinking on the Y, right? We have a similar problem if we bring this back up and then shrink on the Y. Now he's sort of short, right? So what we should do here to compensate is realize that we have our height is too short to maintain the aspect ratio we care about, so we shrink our viewport on the width here. So the best way to do that is to just track the aspect ratio we want to adhere to, and then ensure that our viewport on the OpenGL side adheres to that aspect ratio. So let's start with adding a float here. Aspect ratio. And then we'll just initialize it to literally 16:9. Oh, I'm not sure why this is showing up as red. Okay, try to run that. I think this is just Visual Studio being silly. Yeah, everything's fine. So I don't know what it's complaining about here. But we have an aspect ratio now. We're initializing to 16:9. So when we create the window, sort of after we've got OpenGL set up, we need to check what the window size is, and then, so maybe I'll just have like a helper method for this, because we are going to have to handle the situation where the user manually resizes the screen as well. So down here in the privates, let's just add a void handle resize, and it should just take a width. It'll be in integers because window sizes are in integers. Width and height. So in handle resize, we're going to get the width and the height of the window itself. And what we need to calculate is what the width and height of our sort of frame buffer should be, specifically when we're rendering to the screen. So we're actually going to need to remember that frame buffer size that we want. So let's go ahead and store that, maybe just down here. And then to calculate that, we're going to need to know the aspect ratio that's being set in our Windows properties. So maybe we'll just keep a copy of this as well here. So first, let's when we call create, let's set it. So that'll copy it over, and then here we're saying initialize screen render. We should also say, we'll call that handle resize for the first time with the current width and height. Okay, perfect. And so now that we have m frame buffer size, which we don't need to initialize because we're going to set it here as soon as we create the screen, but we'll basically want to calculate how to fit, let's say our aspect ratio is 16:9. We want to calculate how we can fit 16:9 within the current window, regardless of its current size, right? So we'll do that first. And the way we'll do that is by taking the width and the height of the screen, putting it through the aspect ratio, and seeing what we get on the other end. For example, a proposed frame buffer width would be the window height that we've got times and window properties dot aspect ratio, right? So take the height multiplied by the aspect ratio. That'll give you a width that adheres to the aspect ratio given this height. And now we can do the same for the height. Framebuffer height equals width times, and then because we're doing the width this time, we have to do 1 over the aspect ratio. So 1.f divided by window properties dot aspect ratio. And then I guess we should cast both of these to ints because we will get floats out. Okay, now we're saying if we were to adhere to the window's height, here's what the width would have to be to maintain this aspect ratio. Similarly, if we were to adhere to the window's width, here's what the height would have to be in order to adhere to that aspect ratio. And now what we can do is just pick one, right? So if, let's say, the height is greater than or equal to the frame buffer height, which means does the window have enough space to support the proposed frame buffer height? And if so, then we can just change our frame buffer width to that of the windows. Because we're saying, okay, we can take up the entire width of the window and we'll have this sort of shrunken height that is less than the height. And then otherwise, which means our frame buffer height will be that of the windows, and then we'll use the frame buffer width up here that is sort of calculated from that aspect ratio. Okay, and then we can just set our frame buffer size to frame buffer width, frame buffer height. So to recap, we have a width and a height of the screen. We're saying, okay, if we were to adhere to this width for our aspect ratio, what would our height be, right? That's what this is. And then if we were to adhere to the height for the aspect ratio, what would our width be? And then we just pick one, right? So if we're saying, yes, we have enough height to support the width, then we'll set the width to that of the window. And the height will remain what it is from up here. Otherwise, we're saying, okay, we don't have enough vertical space, so we'll have to sort of adhere to the height. So we'll keep the height what it is on the window, and then width will stay what it was, what we calculated up here. So now let's actually adhere to it, right? Here, when we're trying to render this texture to the screen, we have to set that model matrix. That's why we kept the model matrix up here. So we can actually scale this down so that it fits within these parameters that we've defined. So we should calculate the scale using frame buffer size, which is what we need our frame buffer size to be, divided by, I guess we have a get windows or get size, right? Yeah, get size. And this returns an ivec2. I need a vec2. So glm vec2 get size. So what I'm saying, the frame buffer size divided by the window size itself will give me the scale I need to shrink this down by. So now we'll have our model matrix. And then we'll scale that model matrix by scale.x, scale.y, and then just 1.f on the z. Now scale does need glm. Matrix transform, good. And then we'll just set the model on the shader before we draw. And that should be all we need to do. Now we've scaled this down, and because we are rendering from -1 to 1, our scale actually happens from the center of the screen, which means we don't have to move it or offset it in any way in order to get the sort of black bars, to be centered. We're actually not handling the event when we manually resize the screen, so we'll need to do that here when we pull the events. So the case is STL window event, and then we'll just check if e.window.event is STL window event resized, and if it is, then we can just call our handle resize. And the new size is going to be stored in e.window.data1 and e.window.data2. Okay, let's try that now. Okay, so now I'll shrink this, and there we go. You can see that it looks like the aspect ratio is maintained because it shrunk a little bit, but it's not skewed or stretched, right? If I go even further, you can see it's centered and it's sort of cropped. Now, we can't really tell how cropped it is because we're still rendering sort of everything to this cornflower blue color. So we should just maybe reset the clear color before we render to the screen to black. So that could be like our bars. Our bar color will be black. So here, just before we do anything. We can just set up our black bars. We'll just manually change GL clear color and GL clear. And I'll clear depth as well. Okay, let's run that now. And moment of truth, there's our black bars. So now we're properly centering everything. If I try the other way where I make this too short, you can see we properly reduce the width of our frame buffer here, and we're kept with the black bars on the sides. And it's already centered for us because our vertex array goes from -1 to 1. So we're going from -1 to 1, which means 0's in the middle, and then we scale it down, which means we go from like -0.8 to 0.8, which means the rest is just filled with that clear color that we're not rendering to. So perfect. This works exactly like I want it. But now we have another problem. It's this game view. It doesn't have the same thing, right? Like we're cropping it if it's too small, and if it's too big, we're not using all of the space. So I basically want the same kind of logic, where this sort of just fills up as much as it can based on the size of this. So let's do that next. That'll be pretty straightforward. Just in main, where we render our game view here. So yeah, we're currently just setting the size. We'll just calculate the size based on the size of the ImGui window and the aspect ratio we want to adhere to, which is a good point. We should probably take that logic, this in particular, like anybody should be able to provide a width and a height and get back sort of a glmvec2 with a size that adheres to the aspect ratio of the screen within this width and height. So let's just pull that out, maybe into, and I'll have to call it externally. So we'll do a glm. It'll be an ivec2, I guess. Maybe get size in aspect ratio. Yeah, I think that makes sense. So give me a width and a height that adhere to the aspect ratio within this width and height. Yeah. Create it, and we're basically just going to move it all there. And then this will just be get size in aspect ratio for width and height. And here we'll return that. Perfect. So in main.cpp, we're going to be able to use that now. So first let's get the size of the ImGui window itself. That's an imvec2 win size, let's say. And the call is ImGui get window size. That'll get you the size in pixels of the current window, in this case, the game view window. Okay, and now I can track a glm ivec2 aspect ratio size, and it'll be the window get size in aspect ratio with the win size.x, and actually these are, I'll have to cast these to ints, win size.y. Perfect. So our size will just be this ar size.x, ar size.y. And it has to be an imvec2 for this to take it in, so that's why I'm doing that this way. Our UVs should stay the same. And we should actually, that should be enough to actually get a resizing. Okay, 180 didn't like that. Oh yeah, so these are ints, I have to cast them to floats here. Okay, and there we go. So this is resizing. It looks like it anyways. Yeah, perfect. That's exactly what we want. And then if I go too small, okay, it goes a little off before it starts resizing. The reason for that is because the title bar height is not taken into account in the width height. So it actually thinks it's taller than it is. I think that's right. So the only other thing I notice is that we're not offsetting the image itself, right? So this should be offset down to be centered. That would look better. And yeah, this is basically, I don't want there to be a scroll bar at all. Okay, so that's easy. Let's just shrink this down a little bit. Sorry, so we'll take the size. The size actually on the width side looked okay. I think on the high side though, let's just remove like 30 to start and just see if that's enough. Oh, close. Okay, let's do 35. Okay, perfect. That means, so here we're shrinking on the Y and we don't have a scroll bar, which is good. That means we're doing it correctly, and that looks pretty centered to me. And then if I do it on the X, it goes a little close to the edge. I can't tell if it's actually going off. Let's remove a little bit just to make it look right. I don't know, 15. So I want to make sure I definitely see the whole thing. Oh yeah, I was totally cutting it off if that's how much 15 took off. But this actually looks, this looks even now from the left here to the right here. Yeah, that's perfect. And now let's just offset it. So that's easy to do. We just take the difference of the window size and the size we actually used and then times it by 2 so we know how much to push it off by. So let's do, after we've calculated the size, we'll calculate the position. So the x will be winsize.x minus the size.x that was actually used, and then just times 0.5f. So we only push it off by half. And then we'll do the same on the y. That should be good. And the way we offset it is within this window, we can say ImGui set cursor pos. And we'll use the pos here. Okay, let's try that. Okay, it looks like it's working, but I think it goes a little too high there. Probably to do with that sort of 35 and the title bar here. So I think we just have to push it off by another little bit. Yeah, like there's more empty space on the bottom than there's on the top. So let's just push it down by a little bit, like 10. So I guess I'll do that and then add 10 to it. So we'll make it 7 and call it. That looks okay. I think it's still closer to the top, but I think that's fine. I can live with that. But yeah, there we go. So now our ImGui view, it's also stretching properly and maintaining that aspect ratio that we care about, which is important because it means we can render the game at a very specific resolution and just see that regardless of how big or small our window is, right? We'll properly sort of have our black bars on the side to accommodate. So that's excellent. That's exactly what we want. Now, one last thing I think I want to do today is actually be able to toggle between rendering to the screen and rendering all of the ImGui stuff. So I think I'll just have maybe like a bool here, ImGui enabled, which will set the true to start, because now we're on the editor side, and we know we're gonna look at the editor more than we are gonna look at just the game. So I'll enable it, and what we can do is have this entirety of ImGui just only render itself if it's enabled. And yeah, I still have all this offset stuff that isn't even relevant anymore, so let me just clean that up as well. While we're at it. Don't need a window size. Yeah, don't need any of this. I guess I do need this, because this is using the rect pos and size that we control from down here. So I'll leave that, that's fine. But we'll just do a quick check here. So what's tilde? Oh, it might be, yeah, it's grave, I think. I usually use tilde for these. So if I hit tilde, or what I think is called grave, then we'll just say ImGui enabled equals not ImGui enabled. So flip it, and then we'll say, let's get the window. I'm just gonna go down here and grab this, so I can call the windows set should render to screen to not ImGui enabled. Okay, perfect. Let's try this. Okay, so now we're in the dock space state, so let's put everything back where it's supposed to go. Make that tiny, eh? There's our game view nice and centered. Oh, it looks so good. Oh, we're still rendering to the screen because, yeah, that's on by default. So if I toggle tilde, there ImGui disappears and I see the full screen. If I toggle it again, now you can see it's no longer rendered behind us. That's perfect. So whenever I want, I can hit tilde and just look at the game as a player. I can hit tilde to get back to the editor. Let's just fix that last piece there where up here in initialize, I'll just set it to false. And I need to know what window is, yep. Okay, perfect. Let's give that one last shot. Yep, so you can see it's not rendered behind the screen anymore. Now it is, and now it's not. Perfect. It's already starting to feel much nicer to be in here and to work in this, so that's great. So that's all I wanted to get done today. Thanks so much for sticking around. Please give me a big thumbs up if you enjoyed the content, and I'll see you in the next video. Cheers.